What is predictive coding? To talk about this, I would like to start with the big picture. Why predictive coding at all? And then we will be looking at the mechanism behind, namely the Bayesian inference. And at the end, I'll give you a few everyday life examples to show how ubiquitous this predictive coding model is in our daily life. When we look at the big picture, we have to look at the role of cognition. Throughout this semester, we learned that the role of cognition is to help organisms to survive and to reproduce. And in order to do that, there are a few basic questions cognition has to answer. First one being, how do I acquire and organize the knowledge of the world so that I can better survive? And how do I make predictions about the future so that I can better survive the future? And how do I interact with others and the world so that I can better survive and reproduce? On top of these questions, there are two major challenges cognition is facing. The first one is uncertainty. Our environment is partially observable, non-deterministic, and unknown. So the first challenge is, how could cognition predict the future uncertainties with this very limited knowledge of current world and environment? The second challenge is the economy of cognition, or the energy efficiency. Because our brain weighs about 1.5 kilograms, only 3-4% of our total body weight, yet it consumes a whopping 20% of our daily total energy consumption. This means our cognitive resource is very, very expensive. We have to be really frugal with it, only spend it when absolutely necessary. Luckily, during the course of evolution, there are certain mechanisms developed to cope with these challenges. They have fancy names. For uncertainty is the Bayesian inference model, and for the energy efficiency is the predictive coding. The Bayesian inference is a method of statistical inference which is used to update the probability of a hypothesis as more evidence or information becomes available. The goal of the system is to make good enough predictions under uncertainty. You see in this graphic, the orange curve represents the prior belief. This is the system's internal model based on the past data. Based on this model, the system makes predictions, or we have expectations. And the blue curve represents the new data, what actually happens in reality. Usually we get this data through sensory input. And the difference between our prediction or expectations and reality is the prediction error. This is where we pay attention to, as this is the only information that we actually need in order to update the internal model, the prior belief, so that hopefully in the future we can make better predictions. We can minimize the prediction errors. Now let's look at the Bayesian brain. We have the unpredicted environment through which we get sensory inputs so that we have perceptions. And we have the internal model based on prior data, which gives us predictions. And the difference between the prediction and the perception is the prediction error. They come as a surprise and they draw our attention because this is the thing that we want to minimize. So in order to minimize the prediction errors, either we integrate the new data using these prediction errors to update our internal model so that in the future we make better predictions. The error would be minimized, which is called minimizing prediction error by learning. Or we use actions in which we modify the environment to fulfill our expectations or predictions. This is, for example, When we enter a dark room but we expect it to be bright, we would use action to switch on the light to bring the prediction error to zero. Now, let's have a look at the predictive coding theory. Again, we have the environment and the organism. In this case, it's us. The environment gives us inputs, so we have prior experiences based on which we develop the internal model. We call this model a hierarchical generative model. It's probabilistic, and based on this probabilistic model, we develop predictions. The environment, on the other hand, gives us sensory inputs. But please pay attention here. Instead of passively receiving the sensory inputs, we actually actively filters and processes these inputs with our predictions. And since the future is intrinsically unpredictable, there will be prediction errors. And of course, these prediction errors come as a surprise and they draw attention. Since the result or the goal is to minimize the prediction error, there are a few different ways to go. Option A is to say, oh, this must be an illusion. This is called explain away. This is the easiest solution because you just say the errors are illusions, and so you don't need to do anything anymore. It's the most energy efficient way to solve the problem, to minimize the prediction error. The second option is to update the internal model, feed forward, so that in the future we can have better predictions, so that we minimize the prediction error. This is called feed forward, is because the feedback is from a lower level, namely the sensory inputs level, to a higher level, namely the cognitive function level. The third option is taking actions. So you modify the environment to meet your expectations or predictions to minimize the prediction error. Now I have 3 examples for predictive coding in daily life. First one is dopamine coding. Dopamine, as we know it, is a neurotransmitter which usually is referred to as the reward molecule. It reinforces the actions or behavior that triggers the release of dopamine. However, it is also involved in aversive behaviors, so the reward as a term is not really accurate to describe its role. The better way to describe it in neuroscience is actually the predictive coding. So dopamine coding emphasizes on the difference between the expectations and reality. So the surprise. If the surprise is positive, then the behavior that triggers this positive surprise would release dopamine so that the behavior gets reinforced. However, if the surprise is negative, is unpleasant surprise, dopamine is also released, but it would inhibit the future repetition of this behavior. In both cases, the emphasis is on the surprises. In other words, dopamine reacts to the prediction errors. To bring this more to context, think of music. When we listen to the music we like, we have elevated dopamine levels, so our mood is elevated. We feel good. This is because our brain loves patterns, and music usually have these repetitions. It repeats itself. However, the real high, if you have ever listened to any song, you know this. It comes from the violation of expectations. This is when the repetition of the main melody stops. It's when the surprise comes. This is where the biggest surge of dopamine is out there. This is where you feel real high. The second example is an experiment done by a group of MIT students. They went to beer pubs with 2 beers to ask their subjects to taste them and give a preference. The first beer is just a normal lager. The second one is still the same normal lager with a few drops of balsamico vinegar. And they named the second one the MIT Brews. So in the first round, they didn't tell the subjects what the second beer is made of. They just told them this is a different beer. And 60 to 70% of the subjects actually preferred the second beer. They must be thinking, oh, MIT brews, that must be an intelligent beer. However, after being told what the second beer is made of, only 20% of them still prefers the second beer. So you see how powerful this predictive coding is. With the knowledge of what the second beer is made of, everybody seems to at least 50% more seems to taste the balsamico vinegar. While without knowing that, without this prediction expectation, they didn't. And this changed their perceptions and changed their preference. So is the result of predictive coding. The last example, I'm afraid, is a very common one. If you ever argued with your partner, you must be familiar with the scenario. After the argument, the next day, you may start to talk sense with each other. And very often, this would end up into the discussion of, oh, I said this, you said that, I did this, you did that. And very often, what you think happened and what he or she think happened don't match. And how could this happen? Well, not only that you have different memories of the same episode, rather you have the different perceptions of the episode to begin with. You ask why? Well, because predictive coding. Since you're two different individuals with different prior experiences, different internal models, you make different predictions. And based on these different predictions, you, as we remember, filters and processes actively your perceptions. So, very naturally, you have different perceptions of the same episode to begin with. So, next time when this happens, try to stay calm and understand that it's not your fault, it's not your partner's fault, it's the fault of predictive coding. So, having said that, I would like to hand the floor to Clemens, who would introduce the specifics of Andy Clark's model on predictive coding. So, Clemens, please, the floor is yours.